All right, so I know at the end of the last video I had ignored that last proof. That's only because now we're going to start to focus on the proofs in these next two sections. All right, so when we're proving triangles congruent, what we're going to talk about today, we have two of them, SSS and SAS. So SSS stands for side, 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 congruence. And what it says if three sides of one triangle are congruent to three sides of a second triangle, then the triangles are congruent. So ultimately what you're going to see is when you're writing your two-column proofs, you're going to be seeing that you're proving the triangles congruent. That's ultimately what your goal is. So if we remember back to when we did proofs, these are two-column proofs where we have a statement side on the left and a reason side on the right. We number our steps, and the first statement that we always write is we're recopying above what it says in the given. So that has not changed. So we're recopying everything that's written above right next to where it says given, and our reason is given. Okay, now before anything else happens, you want to mark what you have so far. So we have two congruent statements. So it says GH and KJ are congruent, and HL and JL are congruent. So in order to prove triangles congruent, we've got to see if we can get another side in there. So the other bit of information that was written in the given is telling us that L is the midpoint of JK. Well, if L is the midpoint of JK, what that means is that L is in the middle. So that means it splits it into two equal parts. So what I'm going to do is use that piece of information from the given, and I'm going to use my definition of midpoint to say what that means. So if we said that L is in the middle, that means that GL is congruent to KL, which now has gotten me that third side of that triangle. So you know your proof statement is always the last one. It only takes three sides being congruent to prove the triangles are congruent. So now we know these two triangles are congruent, and we're going to write SSS, which stands for side, side, side congruence. So we're only focusing on two of them today. So side, side, side congruence is the first one. But you have to be able to somehow in your proof have shown that three sets of sides were equal to each other. Number two, let's set everything up first. I'm just going to abbreviate S and R. So QRS is isosceles, QR is congruent to SR, and RT bisects QS at T. So I have my given. And within that given, I know that QR and SR, that's all I have. Okay, and I'm trying to prove that the left triangle is congruent to the right triangle. So the other piece of information that was in the given was this. It says RT bisects QS. All right, well, if it bisects it, it does a very similar thing to midpoint. It cuts it in half. So I'm going to use definition. I'm going to write segment bisector. And what that did is it told me that QT was congruent to ST. It split that segment in half. Now, what you notice is these two triangles, we need to get that third side. And that third side, though, is shared by both of those triangles. So they have that in common. So this is, remember, if we go back to that reflexive property, which said that the same item is congruent to itself. So we're going to say that RT is congruent to RT by the reflexive property. And that has now allowed us to get that third side. So now we go to our proof statement, where QRT is congruent to SRT, and that is our SSS congruence for that. All right, so changing gears a little bit, no more two columns for just the next two problems. So it says in two triangles, we have all this information, all these congruent statements. We're going to draw the triangles and write a congruent statement for the two triangles. So first, let's sketch. Now, when you start labeling, don't just put stuff everywhere. What I would try to do is go in order and make life easier for yourself. So if it's saying that PQ is congruent to ML, well, if I'm going to put PQ here, then I want to put ML in the same exact position because P matches with M and Q matches with L. then it says PR is congruent to MR. There's my second bit of information. Well, I have P, which means this is R, and that means M and N need to be in the same location. And then RQ, which I have, and NL, this should be an L, are congruent to each other, which matches up. You don't want to rotate these triangles. You're just going to make it more difficult for yourself. So we said PQ and ML, PR and MN, and RQ and NL are congruent. So our triangles are drawn. Now what we're going to do is we're going to say triangle something is congruent to triangle something. And if you chose to draw it in the same fashion that the congruent statements came, it's going to be nice and easy. So I'm going to start at P, and I'm going to work my way around the figure. I'm going to go PQR. So if I'm going to go from P to Q to R, I got to do the exact same thing in the other triangle. So I'm going to start at M, and I'm going to go M to L to N. Now you can change that up and do it in a different order. Just make sure that they are consistent with each other because order is important. Okay, but if you draw the triangles consistently, your life will be a lot easier if you choose to do that. All right, next one. I would pause the video, see if you could do it yourself, and see if you match with the example or the answer I'm about to write later. All right, so again, pause it. I'm just doing it right now, and I'm just following the same mentality that we just did for the last one, where I'm matching them up in terms of location. Because if you match it up in terms of location, then writing your triangle congruents, they don't need to be in alphabetical order, but they do need to match with each other. So that is one variation of something that you can have for that. All right, now the second one we're going to go over is side angle side. So what that means is you have two sides, and the key is the included angle. So when an angle is included, it has to be between the two sides that are congruent. So if you look at the triangles on the right, angle B is between AB and BC. Angle E is between DE and EF. So that is the included angle. If we look down here on the proof, if we look at these two outside triangles here, that's one and that's two. This angle is included between these two sides. It's in between. This angle is included between these two sides. So if I ignore this proof for right now, I can then say that triangle BCF is congruent, go the same order now, with DCE by side angle side congruence, because the angle is in between the two sides. All right, so a little more practice here just with determining, am I using side angle side? Am I using side side side? Do neither of them apply? So it says determine if these triangles are congruent. If so, identify what theorem. So we only have two so far, side 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 or side angle side. And we're going to write a congruent statement, but that only applies if they're congruent. So if we look at A, we've got a side. I'm just going to put an S. We have an angle. We have an angle. And we have another side. Okay? Now, you ask yourself, it has to fit either side, side, side or side angle side. So if it's this one, it would be side angle side if it worked. But in order for it to be side angle side, the angle has to be included between the sides that are congruent. So this triangle works because we have side, angle, side. So that matches up. But this triangle, I have a side, an angle, and then I've got this side that's all the way over here. So that would not be side angle side. Therefore, there is none that work for this one. So if it is not congruent, then you cannot write a congruent statement for it. All right, for B, we have a side, we have an angle, and we have another side. And the angle in both cases is in between the two sides. So yes, this is congruent by, we're going to say SAS. And if we're going to now create ourselves a triangle congruent statement, let's say I go BCA, again, I need to make sure that I'm consistent. If I go B to C to A, then that would have to match with Y to Z to X. So 3 parts to that, yes or no. Side angle side is part 2, and then that triangle congruent statement is the other one. All right, here we go. So we've got side, we've got another side, and we have an angle. So if it's an angle, we're thinking side, angle, side. But the problem is that angle has to be between the two sides, and it is not. So this is another instance where none would work.